Hello everyone, myself Dr. Ranjana Gogoi, Associate Professor of Statistics working at Gorgaon College. Today, I am going to present a topic taken from one of the most important branch of applied statistics, that is statistical quality control. The topic is statistical process control and process variability. It is taken from BSc CBCS 4th semester statistics honors and BSc non-CBCS 6th semester statistics major courses under Dibrugarh University. The first objective of this presentation is to present the basic statistical process control problem solving tools known as the Magnificent Seven, and to illustrate how these tools forms a cohesive practical framework for quality improvement. The second objective is to describe the statistical basis of the Seward's control chart, and the third objective is to discuss about the process variability and the causes of quality variation. Now, I am going to discuss about statistical process control. If a product is to meet customer requirements, generally it should be produced by a process that is stable or repeatable. The process must be capable of operating with a little variability around nominal dimensions of the product's quality characteristics. Statistical process control is a powerful collection of problem-solving tools. It is useful in achieving process stability and improving capability through the reduction of variability. The 7 tools of statistical process controls are histogram or stem and leaf display, six sheet, Pareto chart, cause and effect diagram, defect concentration diagram, scatter diagram, and control chart. These tools are called the Magnificent Seven, are an important part of SPC. They comprise only its technical aspects. SPC builds an environment in which all individuals in an organization desire continuous improvement in quality and productivity. This environment is best developed when management becomes involved in an ongoing quality improvement process. Once this improvement is established, routine application of the Magnificent Seven becomes part of the usual manner of doing business, and the organization is well on its way to achieving its quality improvement objectives. Now, I am going to discuss these problem solving tools one by one. The first one is histogram. It is one of the most fundamental SPC tools, as well as it is most fundamental graphical representation of statistical data. In SPC analysis, histograms are often used in combination with control charts to dig into variations and determine whether processes are in control or out of specification. In this control chart, this is the LCL, lower control limit, this is the upper control limit, and from the histogram, it is seen that the process is outside the upper control limit and lower control limit. Hence, we may conclude that this process is out of statistical control. Next one is stem and leaf plot. It shows the spread and distribution of a data set. Here a simple example is given here to describe stem and leaf plot. Stems represents the first digits of the data points. Count represents, these are the counts, represent the number of data points with that first digit. Leaves represents the second digits in the data set, numbers from 0 to 9. So median is the midpoint in the data set and is shown in next to the leaf. Here, this the 4 is at the midpoint of the distribution So this is the median value is 4141. Next tool is Sexit. A Sexit is a structured prepared form for collecting and analyzing data. This is a generic data collection and analysis tool that can be adapted for a wide variety of purposes and is considered one of the 7 basic quality tools. In the early stages of an SPC implementation, it will often become necessary to collect either historical or current operating data about the process under investigation. So, a Sexit can be very useful in this data collection activity. When designing a Sexit, it is important to clearly specify the type of the data to be collected, the part or operation number, the date, the analyst, and any other information useful in diagnosing the cause of poor performance. In this problem, it is taken from a computer-related problems. The problems are identified like this, categorized like this, network problem, server problem, etc. And at different time points that are collected, and thus the problems are identified and then take corrective measures for quality improvement. Next tool is Pareto chart. The Pareto chart is simply a frequency distribution or histogram. Here it is given a bar diagram of attribute data arranged by category. For different category, different bar diagram is drawn here, and it can be used to determine which causes of a problem occur most frequently. Next tool is cause and effect diagram. It is a tool that shows the relationship between an effect and possible sources of variation for these effects. As shown in the figure, the effect could be a problem that needs to be solved. The causes of the problem would be then listed on the cause and effect diagram. So these are the causes identified by different team of this manufacturing company, and these causes are joined in a central line, and all the team gathered together and discussed about the problems, and a corrective measure is brought out to solve the problem. Next one is defect concentration diagram. It is a visual representation. It may be a diagram or a map. It shows all defects. These are the defects identified. And as a research tool, it may begin as a blank diagram. First, it is a blank diagram, then defects are identified and marked like this. And after that, corrective measures is taken. Then it is scatter diagram. It is used to show the relationship between two kinds of data. It could be the relationship between a cause and effect, or between one cause and many effects, etc. In the scatter diagram, it is a useful plot for identifying a potential relationship between two variables, and that's why data are collected in pairs on the two variables. And the shape of the scatter diagram often indicates what type of relationship may exist between two variables. Final and most important problem-solving tools in statistical process control is the control chart. Control chart is a graphical display of a quality characteristic that has been measured from a sample versus the sample number of time. The chart contains a central line. This is a quality control chart. This is the central line that represents the average value of the quality characteristics corresponding to the in control line. Two other horizontal lines are there. This one is the upper control limit, and this one is the lower control limit, LCL. These control limits are chosen so that if the process is in control, the process is assumed to be in control and no action is necessary. If a point A plots outside the control limits, then the process is out of control and a corrective action is required to eliminate the assignable causes. So, our next discussion is the theory of variability in the process. That there are two types of variation present in the process. First one is the sans causes of quality variation, and second one is the assignable causes of variation. In any production process, a certain amount of natural variability always exists. This natural variability or background noise is the cumulative effect of many small, essentially unavoidable causes. In statistical quality control, this natural variability is often called a stable system of sans causes. A process that is operating with only sans causes present is said to be in statistical control. The another causes of variation is assignable causes of quality variation. This variability in key quality characteristics usually arises from three sources: improperly adjusted machine, operator errors, or defective raw material. This type of variability is large and usually represents an unacceptable level of process performance. These sources of variability are not part of the sans cause of pattern and is referred as assignable causes. A process that is operating in the presence of assignable causes is said to be out of control. Now, in this figure, I am trying to illustrate the sans and assignable causes of variation in a manufacturing process. Here, this is the upper control limit and this is the lower control limit, and the process is in control. You see here, the process is in control up to a particular time point. In this area, the process mean and variance are inside both the control limits, upper control limits and lower control limits. So the process is in control. But after certain time points, assignable cause presence in the process and the mean and sigma shift to another points outside the control limits due to the presence of assignable cause. The variation becomes large and the process becomes out of control. So, a process that is operating in the presence of assignable causes is said to be out of control, and the process operating with only sans cause, so till this point, sans cause of variation present is said to be in statistical control. So students, I conclude today's lecture here. Thank you.